Hello, and welcome back. It's time for another episode. We are finally in Chapter 9, and I have to give a disclaimer, boys. We are starting to tread unfamiliar waters here. This is not quite brand new knowledge, but it is knowledge Mr. Vey can confidently say he has no confidence in talking about. So I can confidently say I lack confidence. Isn't that an oxymoron? Now, let's dive deep. Let's talk about installing Linux software. We're actually getting to the proper administrative part of this book. We've been going over theory stuff, basic fundamental theory stuff. Now this is the actual, administering servers part of a system administrator book. So pay attention. And because we are going into unfamiliar waters, I'm going to be going very slowly. I actually have to sit down and read and learn rather than just read and review. Today we're going to be talking about installing Linux packages. How does one install Linux packages? Well, there is a utility for that. That utility is called DNF. What is DNF? Well, it's an updated version of Yum. Remember last time when we talked about XKCD and standards? Well, the same thing basically happened here. There used to be an old standard called Yum, and then some high foreheads decided they wanted a newer, better standard, and they made it. And now it's called DNF. Let's dive deep into how to use this utility and how it works. So on Windows systems, if you want to install software, you double click in EXE. On Red Hat based systems, there is an equivalent to that. The equivalent to an EXE is called an RPM, or a Red Hat package manager. Files provided in RPM format come from what is called a repository, which is basically a website that Red Hat or even you could spin up to hold all the different software you normally install on a freshly spun up Linux box. Now, let's play around with RPM a little bit. First things first, we're going to download a RPM. Download. So if you do DNF, download, and then we're going to go for IO top, which is a utility that lets us see disk IO. And then we do an LS, and you'll see we have IO top here. Now, if we wanted to install IO top, we would do DNF install, and then we would point it to IO top, and then it's going to ask us if we want to install. We click yes, and we let it install. Right? So you see how easy that was to get something installed. We knew the package we wanted. We did a DNF download, and then we were able to install it with about one line. Compare that to something on Windows where you go to the website, download the package, double click it to open it up, maybe elevate to admin permissions so install properly, and then you have it installed, and then you have to repeat that for each and every package. With Linux boxes, I could do DNF install IO top, and I could also list a couple of different packages at the same time and install all of them at once. So it makes scripting the setup of a server very easy. Mr. Lowspec is somewhat lazy, guys. I don't like to do work twice. So if I can make a script where I set up a environment the way I prefer and then just rerun that script later on a new virtual machine, I'd rather do that. So we were able to just download that application and install it. Where did it come from? It came from a repository. That raises another question. So many questions, boys. What is a repository? Well, a repository is a store, right? Basically imagine like a website where all the different applications that have been pre-approved by Red Hat are stored. The cool thing about repositories is that you can make your own, and we will during this chapter. Why are repos so important on Linux systems? Well, that has to do with dependencies. Dependencies are basically other applications or software packages that have to be installed in order for the application you're installing to run successfully. Windows has dependency as well. If you've ever tried to install a game on Windows and then you had to install something like Steam, and then you also had to install .NET, and then you had to install DirectX, all those were dependencies for your game to run. On Linux, it downloads the package, but it also downloads and installs the dependencies you need as well. And honestly, you can end up in what is called dependency hell, where you're trying to install a package, but it requires a specific dependency, but that won't want to install, or you can't find the right one, or it's broken, which sometimes does happen. Get started, and let's talk about DNF. We've already spoken about this subject a couple times before, but we're going to dive deep into this. So what is DNF? DNF is the Red Hat utility we use to install applications, search for applications, manage them, uninstall them, and a bunch of other useful things. If you're going to be managing Linux servers, you should definitely know some of the feature sets of DNF. We're not going to cover everything. I don't have time for that. We are going to cover the essentials you need. One of the most useful utilities or subcommands of DNF is the search function. Let's say we wanted to find a web browser and install it from the command line. To do that, we could do DNF search web browser, and we give it a second, and we got no results because I did not spell that right. So learn how to spell, boys. And there we go. As you can see, we have links, which is a text-based web browser. And that brings us to our next utility. Let's say we wanted to install this utility right here. How will we do that? We do DNF install linx, and then we hit yes to install it. And there we go. We were both able to find a web browser and get it installed in a couple of seconds. See why I love Linux so much, boys? Very easy to use. What if there is a file inside of a package? I know that file's name, but I do not know the package name. DNF uses the what provides subcommand to let us search inside of packages to find those files. Let's walk through an example. We could do DNF what provides and then /container file, and it's going to look through all those packages, and it's going to show us all the packages that contain container files. So for instance, we have platform sets, network namespaces, group. There's a bunch of different packages that have a file called container file. We could do the same thing if we were to do /config, and you'll see it shows us all the packages that have a config file inside of them, which is a lot. What if we wanted to get some general information about a package? The DNF info command provides us that utility. So we were to do DNF info linx for the application we installed just a few minutes ago. You'll see we get the package name, we get the version, we get the release date, right? We even get the architecture. This is all very useful information. On Windows, if you want to see all your applications, you can go to Control Panel, Programs and Features, and get a quick view of all the apps you have installed on your Windows computer. Linux has a slightly easier method. You can simply do DNF list. So if we were to do DNF list, this is a list of all the installed packages on our server right now. Very useful. We can even get more specific with DNF list by doing DNF list r*, and it'll list all the packages that start with R. So it's a very useful utility. Before we continue, we should talk about package groups. What are package groups? Package groups are essentially a collection of packages grouped together to make achieving a desired result easier. So for instance, if you wanted to use your server as a virtualization server, you would download the virtualization package group. If you wanted to make a server have graphics, like a GUI, you would download the GUI group. Let's list those groups as an example. So that would be DNF group list. And as you can see, we have different group lists. We have server, minimal install, workstation, virtualization host. We even have server with GUI. It also lists the groups we have currently installed, which is for container management, headless management, and system tools. Now that we have a list of groups, it would be useful if we get some information about a group if we didn't necessarily know what it did. So for instance, I don't know what this smart card support group does. So I could do DNF group info and paste. And look at that. It lists the packages inside of that group, so we can actually see what packages it's installing when we go to install that group. Now, we know how to install packages, we know how to search for them. How do we update packages? There's a command for that, DNF update. So if we were to do DNF update, it would show us all the applications on our server that currently have updates available. So we could do Y, and you'll see it go ahead and starts downloading all our different updates. What if that update broke one of our packages? Well, we can fix that by simply uninstalling it and reinstalling a lower version. First, to uninstall, we do DNF remove linx for that text web browser we installed earlier, right? And you see it prompts if we want to remove, we click yes, and there we go. That removed the package. Having removed the package, how do we go about cleaning up all the metadata and other information from that package? Well, there's a command for that. Like there's a command for basically everything on Linux. We can do DNF clean all, right? And you can see we had 35 files removed. Pretty simple. And that's it. Last time we left off talking about entitlements, or the Red Hat equivalent to Microsoft licensing. And guess what? Even though Red Hat is Linux based, they're still an enterprise, which means registering with them is just as much as a pain in the ass as it is to register Microsoft licenses. First things first, go to Google and Google search register at Red Hat. The second link you find that says create a Red Hat login is the one you're looking for. It's already purple on my end because I've already clicked it. And there we go. Now, it's going to ask if you want to create a corporate or a personal account. For the purposes of this video, we're going to create a personal account. So I'm going to go ahead and fill out this form. I'm assuming you know how to fill out a form, so I'm not going to record that part. I also don't want you to have my information. Sneaky sneakies. But after I've done this and completed this step, we'll continue from there. After you register, you'll then be prompted with this, a verification email. Go ahead and click the link to verify your email. So I changed the format to make things a little bit easier on your eyes. Once you're all nice and registered, you can go ahead and click the Red Hat customer portal, and then from there click Red Hat developer. We'll let that load, and then after we load, we'll go to Red Hat Enterprise Linux, and then you're going to want to download Red Hat, right? Of course, it's going to prompt you to log in again. We're going to do that off screen. And then after you log in and register, you'll see the prompt to download RHEL at no cost. So notice how we had to sign in and register and then sign in again just to get access to this. Once you've downloaded RHEL, you're then going to want to install it. I'm not actually going to go through a video of this. Past me is though. So let's hand this over to past Steven. But we're back and I now have a new VM spun up on VM 1100 RHCSA Lab 1. So this is on Linux. We're going to go ahead and walk through the installation process. So first thing first, we select our language, hit continue, set your default keyboard, set your installation source, select your software selection. So basically this tells you what different packages you want installed. And we want server with GUI installed. We definitely want guest agents installed. Let's see, what other things do we want? Okay, let's see, system tools. We'll want those installed. And then we hit done. After that, we then have to select our installation destination. So we're going to choose default. We're going to go ahead and click done. After that, we're going to choose our default password. Going to go ahead and click done. After that, we'll have to create a user. I'll go ahead and make this user an administrator. Then we're going to set our password for that user we're creating. We hit done. We've got to go back to our installation destination. There we go. And from there, we can begin installation. And we just go ahead and we let it do its thing. So we'll come back when it's completed. So the system install is done. It's booting up now. And we are done, boys. We now have RHCL installed. So that install process should be the same for Alma Linux, CentOS, RHCL. Basically, all those family of distros share the same installer. So if you know how to do it on one, you know how to do it on many. So at this point, we have now finished installing RHCL. Let's go ahead and get it registered. This is the easy part of this entire video, boys. First things first, in order to do this, you're gonna need Subscription Manager installed. On Alma Linux, to get it installed, I had to do a yum install Subscription Manager. This command right here. Once this command is done running, you'll then be able to run Subscription Manager, register, and then from register, we'll do the rest of this. Dash username, and then you enter the username you use to create your account. In my case, I'm going to enter my email, and then you enter the password, and we let that run for a few seconds. All right, cool. And then it gave us a little warning about default behaviors. We're not going to worry about that right now. That's not the purpose of this video. Now that your system is fully registered, you'll then want to go to access.redhat.com/management. Once you get there, you'll see this page right here where you can manage your Red Hat subscriptions. If I had active Red Hat subscriptions I wanted to manage, I would come to this page. And once I'm on this page, I would go to View All Systems. After you click View All Systems, you'll get a list of all the Red Hat servers you have registered. Why would you want to register it? Because when you register a server, it provides you a convenient way to manage them, to also view system and status information about them. And then, of course, if you're paying Red Hat fat stacks of money, you can also call them and ask for help, which is very useful, especially if you don't want to spend a couple months reading a thick-ass textbook and trying to burn the knowledge into your brain. Because Alma Linux is open source, it doesn't come with all the necessary tools you would need to pull full system information. But it does come with some. For instance, if we were to click System Facts, we'd be able to get some basic CPU info about our server. We'd also be able to get information about installed packages, but Alma Linux doesn't have the, again, right tools installed. Same thing for enabled modules. These would be your enabled kernel modules. Alma Linux does not have the right packages installed to pull that. Error data, you'd theoretically be able to look at error logs. Again, nothing we really see here. So thank you for watching, and tune in next time where we dive deeper into chapter 9. This is again, new stuff, so it's going to take a little while for the videos to come out. In our last video, we were talking about Linux repos. What is a repo? A repo is a storage location that holds all the different Linux packages we want to download. Often when we download and install Linux packages, it pulls from public repos. That being said, did you know you can host your own repo? I mentioned this briefly a few videos ago. If you recall, a repo is basically just a website. In this case, it is a couple things. It's a website with a URL, and it's also somewhat of an FTP server that holds packages, the dependencies for those packages, as well as metadata about that packages, like what version it is and what dependencies it needs for it to run. In our last video, we talked about what a repo is. It would be nice if we knew how to host them. Well, we're going to talk about that in this video. Before we get to that though, we have to talk about your repo configuration file and how that is set up, because that's a pretty important part of hosting your repo. The nice thing about Linux is if you want to change a setting or you want to change a configuration, there's a file for that, right? I really like that there's a file for everything, and you can just go in and play with that file and change the results. It is a very convenient way to manage systems compared to Microsoft Windows. It's not that Microsoft Windows is inherently bad, it's just Linux is a little bit easier for my brain to understand. And I'm making these videos for people who have similar brain structures to me. Acoustics unite! Where are your repo files stored? Well, there's a folder for that. That folder is yum.repos.d. Inside of that folder is a list of different repository files. Let's list some of them. And as you can see, we have a bunch of different ones. Now let's look at the contents of one of these repo files. And appstream.repo. No doubt this giant string of text is rather confusing. Honestly, it confused me too until I read through the book a few times. Let's break down what the different portions of this are. So this is the label for your repo source. If we look inside of this file, you'll see we have a couple different labels. Each one of these represents its own repo. So one file can contain multiple repos, and you can have multiple repo files inside of one repo folder. The next portion of that file is the repo name. Again, this is just what we call the repo. It doesn't have to be one specific thing. You can call it whatever you want. After that, we have the repo base URL, which is right here. And it works just like your normal web server. You would point it to a web-based repo. And last but not least is your GPG key, which is used to verify the security and authenticity of your repo. This makes sure that some hacker hasn't set up a repo and is man-in-the-middling the software you're installing on your server. This is very important, boys. In the ancient days, all the way back in RHEL 6, you would have to write this config file yourself. Nowadays, don't bother with it. There is a utility for that. That utility is called DNF Config Manager. Let's walk through using that application real quick. And we'll go ahead and get started. Today's topic is on hosting your own Linux repo. Why host your own repo when there's a bunch of freely available ones on the internet? Well, first things first, it allows you to have control over what packages are on the repo, because sometimes public repos do get compromised. Secondly, it saves you bandwidth because you already have the applications downloaded to the local side of your network, so they can be freely deployed to local resources a little bit easier. So how do you create a local repo? There's a command for that actually. That command is DNF Config Manager. Let's dive deep into DNF Config Manager real quick. While I was away, I went ahead and created a local repo. I have a folder called Repo, and inside of that folder is the basic folder structure for a repository. So we can do ls repo base os, and you'll see we have a packages and a repo data folder. Those are the two folders you're going to need to create the skeleton of a repo. Now that we have the skeleton of our repo created, we can go ahead and use the DNF Config Manager utility to define our very first repo. Let's go ahead and do that. The command itself is pretty straightforward. It is dnf config manager add repo equals file repo / base os. I forgot a D in there. So let's go back real quick and add that extra letter. And there we go. And with that, we've just defined a repo. Now, if we do ls/etc yum.repos.d, we should have a new repo file. And it's right here called repo-base.repo. But we're not quite done yet. We still have to edit that repo, and we have to change one flag. We have to change GPG check to 0. Otherwise, this repo won't work. GPG check set to 0 basically means we are not looking for a security key, which is fine because this is a local repo, i.e. it's a repo that is installed and configured on this local computer. Repos.d and then repo, cool. And you'll see here, it basically just went ahead and defined all our settings to define the name, the base URL. It also enabled the repo, but it still won't work until we set one last flag, which is GPG check equals 0. Cool. And with that, we have now defined a repo. Let's see if we can update from there. If everything worked right, we should be able to run DNF update with no issues. So let's do DNF update and let's see why. And if we had a broken repository, it would throw us a bunch of errors when we tried to update this host. Let's see why. It's doing something. All right, we're at 16 of 206. So this is probably going to take a while. We'll come back in a few minutes. And it looks like it's almost done. That took a little bit there. And perhaps need to upgrade the specs on this VM. And we are done. Look at that, boys. The update completed successfully, which means that repo was configured successfully. And that's how you configure a local repo. We last left off talking about GPG keys. What are GPG keys and how do they work? GPG stands for GNU Privacy Guard. Basically, it's an open source implementation of a private public key pair system. It can be used to encrypt communications, applications, and a bunch of other stuff. It is a very powerful encryption tool, and it is used heavily on different Linux systems and for various reasons. How is this information relevant to Linux repositories? Well, GPG keys are used to sign applications on public repos. So basically, when you set up a public repo, you have your GPG key, and you use that key to sign your applications. What happens is if someone, a hacker for instance, were to try to upload a file to your repo, the keys would not match or it wouldn't have a key at all. And during the check process of installing an application on Linux hosts, it would see the key mismatch and it wouldn't allow you to install that app. I've actually run into this issue a few times on Debian systems. Another way to manage GPG keys is using the RPM command. If we were to do RPM-K./IOTop, you'll see it shows us digest signature is okay. So this one has a valid key, and that key matches the key that we have inside of the config file for wherever it's pulling this RPM from. Long ago, in ancient times, when dinosaurs roamed the land, it was the year 1997 and the RPM command was introduced. What is RPM? RPM stands for Red Hat Package Manager. It is basically the old way you would go ahead and install packages on Linux. This was before repositories, which meant you actually had to go out and find your packages and manually install them. Ugh, disgusting. Imagine having to download software off of bulletin boards using dial-up internet. Or worse yet, having to send a check to a company and having them send you a magazine with a CD inside of it. Truly, old Linux admins lived in hell. Or more specifically, dependency hell. Imagine trying to install Apache in 1997 without fast internet. You then plug your CD in and start to install, only to find out this version of Apache is not compatible. Why is that? Well, it turns out that the version of C++ you have installed is currently incompatible with the version of C++ Apache ships with. So what do? Well, you go to bulletin boards or you hope and pray. Either which way, boys, you're kind of screwed and there's not really much you can do because you will get that dependency missing error. Thank goodness there's DNF, which connects to repos and will pull your dependencies for you and replace incompatible ones. We don't understand that we stand on the shoulder of giants until we go back to how they used to live and realize they were living like savages, like absolute, ugh. Before we get started, I would like to say thank you. I appreciate your support. If you like this content, please go ahead and hit the like button. If you would like to continue getting more updates from me, go ahead and hit subscribe. Otherwise, it's a free country, and I'm glad you took a couple seconds to watch this. Did you know there's a naming convention for RPM packages? I didn't until I read the book. Or rather, I kind of knew there was one because I realized it was following a set pattern, but I didn't exactly know the rules to that pattern. So let's go ahead and get started and explain how your packages are named. First, it starts with the name of the actual package. In our case, we have Links, which is a text-based web browser. So it starts with the package name, Links. Then there is the version of the package. So that would be 2.8.9. Then there is the subversion of the package. So sometimes they might make a minor revision to the package just for bug fixes or security fixes. Then there is the Red Hat version it was created for. In our case, that is EL9 for RHEL9. And finally, there is the architecture the package was made for, x86-64, which means it was made for modern conventional CPUs like Intel and AMD CPUs. When you install an application on a Linux server, an entry gets added to a database. There's actually two databases on your server, one for applications installed via DNF and another for applications installed via RPM. Since we've already talked about DNF, let's dive deeper into the RPM command. What if we want to get a list of all the packages installed on our server? We have two options. We can do RPM-QA, or we can do DNF list installed. And as you can see, they put out the same thing, but DNF is a little bit easier to read. But sometimes DNF might not be installed on your system, or it might not be configured correctly. So the RPM is a nice, convenient fallback. All right then, what if we wanted to use the RPM command to get some information about a package? To do that, we would do RPM-QI, so query information, and then we would do nmap as our test mule. As you can see, we have a bunch of information about that application. You see, nmap is a utility for network exploration or security auditing. What if we want to list all the files inside of a package? Well, that's pretty easy. We could do RPM-QL, and then we can do nmap. So L is for list, and you see it lists all the files that come attached inside of that nmap application. What if we then want to get some documentation on how to use nmap? We could do RPM-QD for documentation nmap, right? And it shows us all the different documentation for nmap. More specifically, one we want to pay attention to is user shared doc nmap readme. So if we were to do this, highlight this one, and then do cat, and then we paste, then we hit enter. As you can see, it outputs some documentation, but unfortunately this readme file is empty, which tends to happen with Linux packages. And that is it, boys. That is the lowdown on RPM files. Thank you again for tuning in. If you like these videos, tune in tomorrow. There's probably going to be more, unless of course it's Saturday or Sunday, because those are my days off of both work and this hobby.